all. Look, today, my name's Craig Hercott. I'm the Managing Director for Enterprise IS. So I'll just be your chairman today in this room, so helping along with all our speakers. So look, just a couple of things. For this particular topic, Nyssa would like to have questions and answers at the end. So if you've got any questions, please hold them up. We've got 5 minutes at the end to have we've got a microphone up the back, so we'll grab that and answer the questions at the end. Look, today's presentation won't be available after the session. So certainly I will urge you to take notes. Nyssa's presentation should be kept. So any notes, take them please, and then in the Prometheus corner, after the speaker's corner, so you should be able to come and answer some questions then. So look, I'll introduce Nyssa here. Nyssa's the maintenance superintendent for Rio Tinto. Look, Nyssa's got experience and she's very passionate in asset management and has a wide knowledge in engineering, maintenance execution and frontline leadership. She graduated, she's got a double degree in mechanical and chemical engineering from Louisiana. She's had a career stretch from the oil fields in Louisiana to the bauxite hills in North Queensland and into the Pilbara. Certainly working full-time, she completed a Masters in Science and Engineering in 21, and certainly Nyssa's had an exposure to whole-of-life asset philosophy through her various roles in the industry, which has allowed her to make some improvements and decisions that are not only sustainable but also focused on good asset stewardship. So certainly I'd like to welcome Nyssa to the stage.
Thank you. Wonderful to be here with everyone today, so we'll go ahead and get started. So a bit about myself, not originally from Australia, so I migrated to Australia in 2016 from the US, that's where I got most of my education from that aspect. It was actually quite interesting in some of the keynote and discussion with the panel this morning around the lack of trades in the US, and I guess some of that stigma around that. I know myself growing up in the US, it was a very high expectation that you went to university, and I know that was a big pressure from my parents, so I've followed that avenue myself. So from there, I've been with Rio for 7 years now. I'm a maintenance superintendent up at Cape Lambert, and as mentioned, I'm very passionate about maintenance and about shutdowns. So on that as well, endless amounts of curiosity, and I'm always looking at how we can do things differently or more efficiently as a team. This next slide is going to be a bit dense, but basically what I would like to talk about is sort of the human-centric approach that you can take to safety when it comes to completing task-based activities. So from that, I've borrowed this model from Fisher Improvement Technologies. So they run human and operational performance-based training, of which I was fortunate to become a human performance advocate while I was up at Weipa with Rio Tinto. And I think that really had an influence on sort of this project that we're going to walk through today. So from that, if you think about a human-based system, a task-based system, you've got yourself as a person, as an individual in the middle, and as a person you interact with people, processes, programs, your work environment, the organisation, equipment, and they all interact with each other as a bit of an ecosystem. What's going on there? Okay. With that, there's also the essential leadership cycle, and so that is how the organisation itself manages people in a task-based environment. So I'm just going to move this on the screen so I don't... Cool. And so that is how the organisation controls and manages this task-based system. And so the foundation of that is the self and team awareness. So having a self-awareness of the ecosystem that we operate within and the tasks that we're performing, and that each individual brings different aspects in their own experience and as well as their own personality traits, such as, I guess, how they manage risk and what their appetite is for that as well. Sorry, this thing keeps popping up. Okay. So what are we trying to manage in this system? So in this system, we're trying to manage error. So, and that error can come from many different places. Specifically, and the definition here, error is an action or inaction that unintentionally results in an undesired, unwanted condition or leads to a task or system operating outside of its limits, deviates from a rule, standard, or expectation. And so with that, when we think about error, it's not necessarily something that a human or a person consciously makes. It can be something that is a result of systematic challenges within their workplace or within their environment that they're working in, and it's important to recognise that human error, or error in general, is there and that it can happen. And so some of those guiding principles and some of the things that I think about, particularly the first one there, is people do what they do at the time that they do it for reasons that make sense to them at the time. So nobody intentionally goes out and like gets hurt. They don't go to work and think today I'm going to break all the rules and violate a bunch of policies and procedures and hurt myself or hurt somebody else at work. And so it's understanding that, and it's understanding that error is something that there's traps out there. There's different traps with error, and that comes as stress, high workload, time pressure, whether it's real or perceived. So particularly in maintenance and shutdowns, there's a lot of time pressure. So we know that that is an error trap for the people who actually perform these tasks. As well as that, so poor communication, vague work guidance. So those are also very important in a lot of the work that we do, and understanding that those are error traps that then put us at risk of actually having an error in the work that we perform. On from that, overconfidence, infrequent or first time performing a task, distractions, working the first day after more than 4 days off, and the end of the shift, or extended work hours. So that all comes back to sort of those circumstances that could lead you to make an error in the task that you're performing. And so as part of this system, some of the tools that they utilise are visualise, point and touch. So that's you see it, you touch it, you verbalise it, so talk through the task that you're performing. You perform a step-by-step, so that's using all of our different tools, SWPs, safe work instructions, standardised work, SWIMs, all those different tools that we utilise. Stop and seek out, so actually, hey, this doesn't feel right. Going and asking somebody who actually knows a bit more than you do about it. Three-part communication, so that is what my mother would call fast food communication. So you say it, they say it back, and then you repeat it back to confirm that that has actually been communicated. Show and tell, so that's a lot of the teaching aspect of a task. And then values-based methods and observations. So that's observing a task being performed and then providing that feedback. So why a human-based approach? Why is this important? So it's important because we know that shutdowns and completing tasks expose people to risk. It also exposes the business to risk. It exposes our asset to risk. And we want to make sure that we employ a process that helps us mitigate that risk to ensure that we're able to prevent an event from occurring. So an event can be a safety incident, it could be a near miss, it could be actually not performing the maintenance the way it was supposed to be performed, and therefore you actually have an unplanned failure as a result of the task that you've not performed correctly. So as part of that, this sort of Swiss cheese model, semi-bow tie model, helps us understand like what we can actually put in place to prevent an event from occurring or to manage it once it does occur. So in shutdowns, for us, a lot of the engineering and design side of it is actually really important. So thinking about maintainability of assets and how we actually perform that maintenance so that we inherently build it into the design so that we can prevent a lot of these errors or these situations that people could be exposed to. As well as that, so using installation operational maintenance manuals, building QA/QC documentation, having access to technical drawings that have the information you need, developing checklists, Gants, etc. Those all also help in preventing errors from occurring in the work that we perform in shuts. And then there's the personal aspect as well. So having the right skills, the right experience and the right behaviours of those frontline teams is actually a really important barrier to preventing an unwanted event from occurring, which is something that I think is very important, particularly to this project that I'll be talking about. And then after an event has occurred, you want to obviously implement lessons learned, so learn from that so it doesn't happen again. And so then you move a control to the other side. You've got recovery plans and other things that are also in, I guess, play after an event has already been detected or happened. Awesome. So how does this relate to people who perform maintenance or work management? So this is a bit of an ecosystem of how many people are involved and what it takes to actually get work done from either routine maintenance or a shut perspective. So it starts with identifying the work. It then goes through to planners. They review all the work, goes through to your schedulers, goes through to your maintenance supervisors, then back to your frontline teams, who then will produce quality maintenance output. And so there's a lot of layers, a lot of systems, and a lot of things that need to go right to make sure that we get the outcome that we want, which is quality work performed. And so how do we do that in a shutdown space? Like, how do we actually make sure we set everybody up for success and keeping in mind as asset management and maintenance leaders that it's our role to govern that process and make sure that each person along the way has a good handover and they are setting the next person up for success in this ecosystem. As well as that, all the technical and engineering inputs and having that feedback loop, so making sure there's a continuous improvement process associated with it is also very important. So that is just something else to take into consideration when you're thinking about work and how it is performed. Okay, so now on to the actual project, so the fun stuff. So this project that I was part of with a bit of a timeline there, so started in the team in 2021, a new greenfields mine. This was going to be our first time performing maintenance. We needed to develop some of that methodology on how we were actually going to do the work. This asset specifically that we're going to talk about is a primary crusher, so a gyro, with rotable components, so rotable spider, main shaft, top shell, and middle shell assemblies. And each of those are very heavy, so about 100 tonne each, well, except for the spider, it's about 46, but everything is very, very heavy, which puts a whole nother level of risk into how we actually perform that maintenance. And this maintenance was every 13 weeks. So every 13 weeks, we'd be changing something out, whether it was a main shaft or whether it was a complete rebuild. With that, lots of critical work, so lots of work that could hurt, harm, or kill you. So lifting operations, vehicle interactions, working at heights, confined space, all of these different things that we need to manage as part of that work. The idea there as well is that we really wanted to drive, that we wanted to get it right, and we wanted to set all the teams up and be able to learn as much as we could so that we could actually do the work safely and set all the teams up for success. So thinking about the human side of it and some of the error traps, so high stress, high workload, multitasking, so time pressures, particularly in shuts and coming up to it, vague or poorly written work guidance, so we didn't really have a solid strategy at the start of this project, and so that is some of the stuff that we were aware of, that it would be our first time performing it, so inherently there's more room for error in that. So some key tools, so step by step, and making sure that we're stopping and seeking out as a team. So back to the timeline. So we'll go through this in more detail later, but basically I joined the operational readiness team at the end of 2020, beginning of 2021. The crusher construction started in about Q2. This project started in Q3 of 2021, and then we mobilised a site short thereafter. As part of that, the crusher was then commissioned in 2022, and our first shutdown actually took place at the end of 2022. So about a year from the time it started, from a maintenance aid project to the time we were going to have our first shutdown, and second and third and fourth and so on. So what did we actually do? So I've stepped this out a bit simply. So our first step was to seek understanding. Our second step was to actually step out the full process. What would it actually take for us to do this maintenance? Identify opportunities for improvement, so apply some lean principles, apply some different ways of thinking, create and deliver the actual project as a team, and then apply that strategy to changing conditions. So, seek understanding. So, what was in the design? We looked at the design, we looked at our 3D models, we talked with the actual designers of the facility itself. How did they actually build it in construction? So we had the opportunity to actually look through a lot of the construction photos before we even got to site, so we could see how they were putting this thing together, what sort of rigging they were using, what sort of cranes, etc. What are going to be our site constraints? So one site constraint identified very early on was this lovely tower crane here, because it was sort of unproven, had some doubts early on about it. So what would we need if that tower crane is broken? What sort of crane do we need to bring in to replace it? How are we going to manage these rotables? I don't know if you can see the clash here in this beautiful model, but the truck definitely hits the structure. So some things that we were trying to take into consideration before we actually did the maintenance to say, what would it actually look like when we do it? Like, what space do we have to work with? How are we going to move everything around? What does that look like logistically? So really having that deep conversation with contractors, with OEMs, with cranies, made really great relationships early on with a lot of those key stakeholders to make sure that we actually thought about what we would need to actually do this. So then stepping out full process, so everybody who's an engineer loves a good whiteboard sesh. So I remember having this on site sort of coming up around Christmas that first year, and going through and being like, okay, what would this actually look like? How would we step this out? What are our risks? What is it going to look like? Start to finish, 2 scenarios, main shaft only change out versus the whole kit and caboodle, and really just identifying risks and unknowns as part of that. So in a bit more detail, the full stepped out process. So I figured if we could solve for the major rebuild, we could solve for the minor ones. So very detailed in that. It was early on identified we would need lots of trucks, and we would need drake trailers, and we would need a big crane. So we would need at least a 650-ton mobile crane to unload all of our rotables, or we'd need 2 300-ton cranes to do dual crane lifts to unload everything, because some of the constraints as well were around the actual transport frames that these materials came on. They weren't really designed to be loaded onto plinths or anything like that. So there was a couple complex items in there that we needed to consider. When we did step it out, being sort of quite modest in our timing, it was going to be about 211 hours from some of the numbers, which was outside of our original constraints, which were 144 hours for that outage to actually perform the work. So immediately a bit of a red flag of we're actually looking at it and stepping it out or outside of what we've actually committed to as a team for how much time we would need for this shutdown. So then let's identify some ways to improve. So first thing was thinking, okay, how can I eliminate waste? And how can I apply some lean thinking? So pull some of that fresh information that I had from my masters and say, okay, well, how can we do this a bit differently? How can we apply some different options in how we transport and move things around? What sort of engineering aids can we employ to actually make it easier to do the job and faster and safer and all those things? Applying the shut management process, so really making sure that we're defining exactly what needs to go into the shut, that we're managing it, that we're setting everybody up for success along the way, and we're always continuously looking for ways to improve. And then applying some of Rio Tinto's safe production system, which is similar to Toyota production system. So applying some of that thinking, that standardization, to then find some improvements. So some of the things that we identified early on was the need for a maintenance area where we could store these rotables, and we could utilize something called a SPMT, so self-propelled mobile trailer. So that's something that we had already had on site at Guidai-Darri for one of our other rotable components. So we had 2 of these, which were purchased as part of the project, and what a great opportunity to then leverage an existing asset to be able to do maintenance a bit differently. So as part of that, we were able to design a maintenance area which had dedicated plinths and dedicated structure and concrete and all the things that you would need to be able to enable that to happen. So that would eliminate the need for all the trucks and trailers. It would eliminate the need for these rotables to be moved off-site and sent back to Perth or sent somewhere else, which in itself is a bit of a feat because they would need police escort because of the size and the weight of those, which takes about 3 months of planning as it is, let alone the turnaround time needs to be less than 36 weeks. So eliminates that issue and enables us to leverage some of that on site. As part of that, we redesigned a lot of their frames so that they could be used for these scenarios and be able to actually maneuver everything more safely, more efficiently. And then I guess with that and the improvements, I've already sort of talked about the maintenance area there a bit, but we also went along the side of what maintenance aids can we design and employ to actually make this maintenance easier. The actual maintenance area itself, so a dedicated area where we could rebuild everything, and then have some contingency plans in the background so that if everything goes wrong, we'd have a plan. In more detail, the timeline. So we had about 18 months to design, fabricate and deliver these 11 custom maintenance aids and frames, as well as a bunch of really cool lifting gear. We had about a year to design, fabricate and construct the actual maintenance area itself, which ended up overlapping with our shutdown. So we were constructing a maintenance area and having a shutdown at the same time, which was fun. And the other side of it was deliver a contingency plan. So with that, some pretty critical events that we've got here. So we had our first shutdown, and in the first lift, we functionally failed our tower crane. So luckily, contingency plan activated, so brought in a 650-ton crane while it was already on site, and used that to perform the rebuild. The second shut, so another main shaft replacement. Tower crane was back in service. We were able to use it for the entire rebuild, but then it failed on the last lift. So back to contingency planning. So then we knew in 10 to 12 weeks, we would need to do a major rebuild, which is all of the internal components would be replaced, and that's going to be really difficult without a tower crane. So we'll talk about that. Whoops, wrong way. So some photos from delivery of maintenance aids. So some really cool stuff. So designed a power shackle, so hydraulically actuated power shackle. So you wouldn't actually have to access it to remove it. So remote controlled, quite cool, 150-ton rating. Some lifting spears for lifting our spider out, which is a lot safer and more stable way of lifting it, rather than using soft slings or chains around the circumference of the actual spider itself, which is this one. It's our spider assembly. And then introducing the different maintenance frames, so actually transporting things on trailers and then offloading them on plinths, so you don't need a second crane, which is great. And then a bunch of other stands to actually hold some of the equipment, because traditionally what people would do is they would lean that main shaft over, so they'd land it on like a tire and they lean it over in sort of a controlled manner, which 100-ton main shaft leaning over in a controlled manner is not really something I feel comfortable with. So the vertical stand was a perfect alternate for that. So the other side of it, so the primary crusher maintenance area, so designing that around using the SPMTs, there were some other challenges that we had along the way, particularly the underground buried services. So because of the axle weights, we were going to overload those buried services. So something that was in the ground for 6 months, we dug it all up and we put in concrete. As you can see, sort of here and there. And that's all stuff that we discovered along the way through having those conversations with the designers, being like, what other things do we need to consider as part of this design so we can ensure that it's successful when we actually get there. And so that's the finished maintenance area with all the rotables put away in their homes. So very 5S in this aspect, where everything is put away nice and neat, has a place that it lives, can be stored there, etc. And then applying that strategy to changing circumstances. So bringing in a mobile crane to perform main shaft changeouts, as well as for when we did the major rebuild. With that, in a bit more detail, was this. So what we did is we didn't just do it halfway, we did it the full way. So got engineered drawings made up so that we would know exactly where everything needed to go, so that it's not just in my brain, it's actually in a drawing somewhere, so somebody else can pick that up and utilise it in the future. It's not just industrialised knowledge that I have and only I have. The other thing that we worked out is did like a full step-by-step in PowerPoint. Everybody loves a good PowerPoint, right? And that actually stepped out every single step that we needed to take as part of the major rebuild, because it was quite complicated. So we had a lot of equipment, we had a lot of trucks, a lot of trailers, so that we could actually do this maintenance outside of the way it was originally designed. And that inclusive of involving sort of the maintenance supervision and the teams that were actually going to complete that, setting them up for success by having lots of face-to-face meetings, having like good comms on the actual days. So there was about 6 contractor groups involved in performing this work. And so everybody would go off, do their pre-starts, their shift starts, and then we'd all collect back together at the work front, and then we would have a bit of a powwow, as I like to call it, where we would go through the work that we had for the day, and then we would make sure that everybody knew what the priority was, everybody knew what needed to be done, and that if there was any issues, they could escalate it. And so we had like my little mission control up there, which was a little sight box, and that had all of our drawings, all of our lift plans, all our technical documentation, everything that we needed, like at our fingertips, printed off, so you didn't have to worry about losing batteries, etc. And it was great, because then somebody would be like, oh, what is the actual mass of this? Oh, let's look it up, let's check, let's recheck that on the drawing. And that was really great. That open line of communication and building that trust with that team was really what led to the success of us being able to perform that maintenance for the first time within the conditions that we had to operate. So, conclusions. So, wrapping it up a bit. So, taking a different approach, or taking a people-centric approach, enables the ability to better collaborate between site teams, between contract teams, and between I guess, individuals performing work, particularly in major maintenance. It is really important to leverage that time during operational readiness to be able to actually learn and to develop the most efficient way to complete maintenance once that asset is handed over, especially making sure that we're identifying those error traps early on and mitigating them through engineering controls. Replicate learning, so that was really important as well. So replicating learnings from both industry, construction, other places, using alternate ways of doing work, really great. Applying lean principles, so that in itself resounds with a lot of engineers. We want to find efficient ways of doing things. We want to make the right way and the safe way the easy way. Holistic thinking, as well as making sure that you've always got that plan B, you've got that contingency plan. You don't always hope that it's going to work. You say, okay, well, if that one doesn't work, what are we going to do instead to actually be able to deliver a safe result on the ground? And then embracing that ownership. So own your tasks and own that work, so that when you deliver it, it can really show how much you care about the success of that project and of that work. So, and that's it. I'm sure somebody has a question, so let's go have some questions.
Thank you. So, any questions?
What questions?
As Nyssa said, I'm sure there's got lots of questions there.
I talked a lot, so now it's your turn.
Not so much a question, but probably more an observation.
Yeah.
Am I not allowed enough for you? No, I was just going to say, not so much a question, but an observation. So we've actually got quite a few people from our maintenance departments here, but under our team, we do our major maintenance projects under capital, specifically down at the fixed plant. So a lot of the work that you're talking about here resonates a lot with the team that we do. And the interesting takeaway for me that I'm going to work on with my team is the fact that the first step in your process was operational readiness. When at Fortescue, anyway, that we find that team actually comes in at the end. So they actually, come in at the end to get your maintenance strategies put in place, to get your SWIs put in place and form part of that project closure and handover, whereas the name describes where it should be, which is your operational readiness at the start. So yes, we've got our design and yes, we know what we need to do, but how is the operation going to be ready to maintain this major asset when you hand it back to them? So it's an interesting takeaway for me, because I think I actually might work with those teams to flip the script and actually say, okay, the first step we need to do is actually have that meeting with the operation, with the maintenance teams, and say, hey, if we go and change this scalping screen to a roadable scalping screen, and you're now going to change it out every shutdown instead of just replacing the panels, what do we need to do and plan as a part of this, so that when we hand it over to you, you've got all of the equipment and change out requirements that you need, and plan it into the budget of the project? Because unfortunately, the way our cycles work is we already have the budget before we even know what we're going to do. So yeah, it's just an interesting takeaway for me anyway. Thank you.
Yeah, good, thanks. And look, I certainly love the engagement up front, engaging the team, using the 3D model. That was Navisworks, by the looks of it, or something similar. Just engaging the team, working through all the areas that could go wrong and able to pre-plan for that. That's fantastic.
Yeah.
So is there any other questions?
What other questions are there? Oh, two just here?
Go on there.
Very similar. So probably more from an observation piece that I really, really liked, and that was that you demonstrated over a period of nearly 3 years it took you to get to the outcome of what you were after.
Yep.
I think we as maintainers lose sight of that. We try to fix it all at once, and when it fails or doesn't work, that great idea, we just go back to doing it how we always did it. I think that's a real success in itself. But at what stage through that 3 years did you nearly throw in the towel and give up?
There were a few times. So that's a great insight. So yes, it takes a lot of perseverance to see something from start to finish. But I think that's where I felt like I owned it with my team, and that I had to deliver. I couldn't fail. And I think especially once we failed the tower crane for the second time, really was just like, we can't not do this work, because otherwise the team's going to be set up to fail when they come to do the maintenance. There were a number of times there where it's like, why am I doing this? Like, why am I putting myself and why am I challenging everybody so much on different ways of working? And I think in that perseverance and driving that relationship with those teams as well, like I've met some really great people through the project, and they're the ones that I felt like I needed to have a plan to give them so that they could successfully do the work, because otherwise nobody else is going to do it. So that was sort of my thoughts, and I needed to deliver so that they could do the work. So
Your outcome was deliverable for the team, a better life, a better place.
yeah. Yeah, absolutely. Better way of working and a safer way.
Jonathan, you had a question?
Yeah, thank you very much. So fantastic stuff, Nyssa. It's completely unrelatable to me, because obviously this big mining stuff is huge 100-ton assets and all sorts of stuff. What kind of input does a maintenance team have in the design of that asset before it goes in? So before it's handed over to you guys to either do the install or the maintainability, do you guys get a say in the design for maintenance before it's bought off?
Yes, actually. So there were a lot of design reviews. Some of it was set in stone early on, which was way before my time, but there were people involved to present ideas on maintainability, and a lot of that was worked into the design of this greenfield site. And so a lot of that was actually really well thought out, but it was always just thought out until it gets to the ground. And so particularly with this crusher, like after it gets, that's the easy part, getting it to the ground. It's what do you do after that? How do you move it, etc. And so that was some of the stuff that actually didn't really get thought about. And I think it might have particularly been maybe the engagement with some of the teams actually performing the work didn't happen soon enough. Because early on it was mostly engineers that were in ops readiness. So all of us engineers had joined the OR team, so lots of people looking at it from an engineering and a design point of view and bringing their own experience and perspective. And then almost when it was too late, that's when our frontline teams actually joined operational readiness. And so by that point, a lot of it's already designed and in stone, but it still gives you that opportunity to say, hey, this actually isn't going to work, and then, okay, well, what are we going to do about it? And so it's actually seeking that feedback, asking them, like, is this going to work? What do you think about this? Like, having those conversations, like, what about this rigging? Like, what do you think? What should we get for this? You know, that sort of stuff. And then you actually start to pull out other people's experience and start to, actually, I guess, dive into that collective knowledge that's all around us, that we just have to ask that question.
Cool, thank you. Is there any, got probably time for one last question?
With the goal of this process being shared vision for all of your team, can you talk a bit more about the processes or cadences around the ceremonies that you had to create that with the team, how you were extracting that knowledge, reflecting, sharing, and improving the processes?
Yeah, I think about early on, we had a lot of face-to-face meetings where we just sort of whiteboarded a lot. So one of the first meetings I had was with all the actual frontline maintenance team as part of Ops Readiness. And was like, this is sort of what we're thinking from a maintenance aid point of view. Like, what do you think? What have you seen? And then somebody would be like, oh, well, at this site we did this, this, and this. And then, oh, okay, well, we'll try and find the drawings for that. Or do you have a photo of that for when you did it? Or can you draw it on the board? And it's really like tapping into that early to then have a baseline for what they actually expect from a design. And so there was a lot of challenge really early on like delivering different maintenance aids, not like boxy, like it's a round crusher. And early on the designers wanted to give me this big square thing to put around it. I was like, well, that's not practical. I was like, can we have a curved ring that is around the crusher instead of a square box? Like, I can get a square box from a SCAFI. A SCAFI can build me a square edge protection. And so is having those face-to-face meetings, understanding like what has previously been done, and then challenging that to say, well, I don't want to construct it in the crusher. I want it to be lifted in as a single piece. So construct it outside and lift it in. So that again changes your design parameters. And so we had all those meetings like pretty regularly. So every week we would have either a Teams meeting or a face-to-face meeting with the design engineers for the maintenance aids. And we would feed that information back to the front line to say, hey, what do you think about this? What do you think about doing it this way? Like, does this make sense? And would you be able to easily use this as part of the work that we need you to do? And that feedback loop of just having meetings, face-to-face feedback, and getting that back to the actual designers was pretty critical for getting this work done.
Thanks so much. And look, I'd just like everybody to just thank Nyssa again for the presentation.